Whenever you send the attendance, please send your USN and the name. That's all. Your USN and name. There is no need of present, sir. Just write your USN followed by your name. Okay. Um, Before we start our lab, first I want to show once again the syllabus. This syllabus I have shown in the first lab, I think. Once again, I want to show you because many of you are for lateral entry, no USN. Mhm. Okay. When you get the USN, you can update. Okay. Okay. See here, totally there are 9 experiments. I think you have already seen all these experiments, but once again, I will show you the syllabus. The subject code is 18 CSL 37, um, and the number of experiments are 9, and 3 analog experiments and another 6 digital experiments. In these 3 experiments, there are simulation also. In the software, you have to do it. And in 3 experiments, you have to do it in a software. That is what this HDL. Then, and also with the same way, hardware you have to do it. Since you have not in the college, what we can do is this simulation part. This is a free software. You can easily do it. And I think everyone has got the software which I have sent in the WhatsApp. I think you have installed. Did anyone faced any problem in installation? I think no one has contacted. Did anyone faced any problem? Can anyone unmute yourself and reply? Did anyone face the problem in installation? In chat also? Okay. In chat also you can reply. Okay. Dinu has replied that no problem. If anyone has faced the problem in installation till now, even you can contact me. And also how to execute all the procedures that we have uh, shared in the YouTube videos. 3 experiments we have uploaded. I think you have watched in that. Uh, but we'll give a brief introduction about all those uh, experiments in this lab, and then we'll go to the digital experiments. See, we'll see this first, the window comparator. I think you have seen in the lab or you have heard the IC called OPAMP, operational amplifier. You have heard this name, operational amplifier. This operational amplifier is going to do so many things. You can use that operational amplifier as an mm, integrator. For integration you can use, for differentiation use, you can use for a comparator, you can use it for as a filter. It is like a all-rounder. You can use it for so many purposes. Since it has so many applications, in that one application is window comparator. We are using operational amplifier. The IC number is 741. That number you are seeing it in the problem statement. 741 is an operational amplifier. In that, one application of the operational amplifier is window comparator. And that window comparator is comparison. Window means some range. What the experiment name is, using a 741 operational amplifier, design a window comparator for any given upper threshold point and lower threshold point and simulate the same. What is the meaning of this window comparator is, I'll say some number 5 volts. That is called as an upper threshold point, and another number 2 volts lower threshold point. If the input, if it is within this range, within the range of 2 to 5 volts, you give me one output, high output or low output. Assume that high output, if it is within range. If the voltage, input voltage outside the range of UTP and LTP, 2 to 5 means 1.5 or 5.1, 5.2, 5.3, outside that range. If the range is outside, then give me another output, low output. That is what they are expecting. You have to use the operational amplifier, and you have to design in that way. This is how the output looks. Input will be an input voltage. Input will be a voltage. You are going to give 1.1 volts, 1.2, 1.3, 1.4. I think you are seeing the pointer here. If that is an input to the window comparator, that window comparator, it is been designed using op-amp. This is how you are going to connect. Don't worry, it looks complex, but two operational amplifier we have used, two operational amplifier, and we have designed, and we are going to give one input. This is an input side, this is an output side. Whenever want to give the input side also, that we are going to, there will not be a digital display to enter 2, 3, 4, 5. In the function generator, you are going to set the values. What is the frequency? What is the input voltage? All those things. There will not be a text box or anywhere you are going to enter 2, 3, 4. This is an hardware, two operational amplifier ICs. What you are seeing here, 2, 3, 7, 4, 6, these are the pin numbers. It's a 8-pin IC. Operational amplifier, it is a 8-pin IC. Only you are going to use these numbers. Which numbers? Second pin, third pin, fourth pin, sixth pin, and seventh pin. Only these many pins we are going to use. What about 1, 5, and 8? They are offset, null, and no connection. And those pins we are not going to use it for any experiments. Only these pins we are going to use, 5 pins. 3 pins are not used. And this is a window comparator. In order to set the range, two operational amplifier is required. First we'll understand the output, then we'll go to the circuit. See here, the input voltage. This is what 0. Whenever we plot the graph, it is with respect to the time and voltage. Input voltage, output voltage. The input voltage is 0, 1, 2, 3, 4, 5, 6, 7, 8, some range maximum. After that, 8, 7, 6, 5, 4, 3, 2, 1, minus 1, minus 2, minus 3. In that way, you are changing the input voltages. This triangle wave, what you are seeing, this is triangular wave, what you are seeing, this is an input voltage. This is how you are giving the input. How it has get generated? You have selected in the function generator what type of input you are going to give. You are going to give triangular waveform. If you can give in the sine waveform or any other thing, any other waveform. What the waveform I have selected is triangular waveform. That is why the input voltages, it looks like this. This is an input. The red line, what you see, this is an output line. The input UTP and LTP, which I have set is lower threshold point, it is 2 volts. Upper threshold point is 5 volts. This is what? This is my values I have given. It is not always you have to use that itself. You can set lower threshold point 5, upper threshold point 10, any range. That is why they, in the problem statement, they have given design a window comparator for any given UTP and LTP, any given input UTP and LTP. It is not, the number is fixed, but upper threshold point should be always greater than the lower threshold point. That is the condition. Is it clear? Next, do you have any doubts in this? If you have any doubts, you can raise the question there itself, or you can send me the message. Do you have any doubts in this? Or you can unmute yourself and you can ask.
No, sir.
Okay. I think till now what I have said, I think this is clear.
Yes, sir.
Okay. Then see, if this is the range 2 volts and 5 volts, if the input voltage, if it is in this range, see the output, it's a low output. If it is outside the range, above 5 volts, it's an high output. Until the input voltage goes below this range, once again, UTP to LTP. If the input voltage, if within this range, once again, low output. This is how they are asking us to implement. This is how they are asking us to implement. If the input voltage, if it is in within the range, UTP and LTP, give one output, low output, or you can reverse it. If it is within this range, high output, outside the range, low output. That's all. This is the normal working, and that is what you have seen in the output. Say here, see, this is what actually you are going to do it in the hardware itself. See, IC, whenever you connect, see here, which are the instrument, first we will see which are the instruments, devices that you have used. See, this is an CRO. In the hardware also, you are going to, you will have the CRO in the lab. These are the two op amps. These are the power sources. Mean power source means the fixed voltage, the voltage what you are going to pass. 2 volts, 5 volts. See, this is the range. 5 volts, the number you can see here, 2 volts. This is the two range you have set. And the input voltage, see here. This input voltage, it is going to the two inputs. I think you know about this plus and minus. Non-inverting input, inverting input. Plus and minus. Both the inputs of the both the op amps, one will be the reference voltage, one will be the reference voltage. Say here for this op amp, for inverting input 5 volts, this is an reference voltage. In this non-inverting input, a reference voltage. This is how the connection should be, or else you will not get that range. And one of the other input, inverting and non-inverting, that will be the input from the function generator. What type of signal it will send? It will send triangular wave. That is why you can see this triangular wave here. What is the range? Minus 10 volts to 10 volts. Minimum in the negative, how much you are going to give? Minus 10. Maximum in the positive, how much you are going to give? Plus 10 volts. Even you can set that minus 100 to plus 100. Any number you can give. And this is the ground connection. See here, this is one another one you are going to connect here. Any doubts? Okay, still everyone are sending the attendance. Okay. See, I think you know about this 4 and 7th pin. They are the saturation voltage. What is that? The meaning of saturation voltage means always the output waveform what you see, it will have some voltage. Whenever you see the output waveform of an op amp, if you check the output voltage, output of the op amp, if you check the voltage of that, it will have some number. What is the maximum number it can give the output? It is this saturation voltage. The maximum it can give is plus 12 volts. That is the meaning of this plus 12 and minus 12 is without this the op amp will not work. And what this number indicates plus 12 volts, and usually we give minus 12 volts for the fourth pin, but here the saturation voltage range what we have set is 0 to plus 12 volts. Usually in the hardware, whenever we do it in the hardware, we connect it to minus 12 to plus 12. In that case, the waveform will looks like this. The higher will be here, the low value will be here. Since we have given this low voltage 0, it is in this range. Understand this, fourth and seventh pin there will be called as a saturation voltages. Saturation voltage means maximum output from the op amp will be this voltage. In this experiment, we have given saturation voltage 0 to 12 volts. Usually, we are going to give minus 12 to plus 12 volts. This pin, this is the reference voltage. This is the reference voltage which is fixed, and from here we are going to give the input. And the experiment, I think, if when the input voltage is within the window, the output voltage will be minus Vsat. What is minus Vsat? Minus Vsat is fourth pin. What is fourth pin? It is minus Vsat. What is negative saturation voltage? 0. The output voltage is plus Vsat when the input voltage is outside the window of UTP and LTP. What is plus Vsat? This seventh pin. Seventh pin is connected to the plus 12 volts. This is what the output. This is plus Vsat, seventh pin connection. Fourth pin will be the minus Vsat. If you understand this much, it is more than enough. Whenever you do with the hardware, you will learn other things. How actually you are going to do is, see the theoretical value 5 volts, 2 volts. What you are going to see in the CRO, those values you are going to write it here. You can see the waveform here. This is how it looks. You can check this. This is a triangular waveform. See, this is within this range, low output. If it is outside the UTP to LTP, high output. This output is 12 volts. This is 0 volt. It is actually not touched this line, but this is a 0 volt. 0.12 small difference will be there. And this is 0 and this is 12. How you got this 0 and 12 output is, this is called low output and this is what high output. That is what this ground and plus Vsat. Whether this much is clear? What is the meaning of window comparator? What is actually this op amp and what actually is the output? Have you understood this? Do anyone have the doubts? Feel free to ask any doubt. It can be a silly question or it can be a Invalid question. You can think it as a nonsense question. Please ask. No problem. Sorry. Still, many are busy in sending the attendance itself. No doubts. Did you face any problem in the whenever you're doing this experiment in the system? No doubts. It is easy for us if you don't reply. It is easy for us that we assume that everything is understood. When you raise the question, then it is complex for us. We have to think what should answer. If you don't reply, it is easy for us. Okay, I think this much is enough for this experiment. Window comparator, high output, low output, within whenever it is in this range. One line answer is this much. You can remember one line answer is if it is within the range of UTP and LTP, low output. It is in the outside the range of UTP and LTP, high output. You should remember that much. One line answer about the window comparator. Range alitta, low output. Range in the ಹೊರಗಡೆ ಇತ್ತ, high output. ಆ low output in voltage ಎಷ್ಟು ಅಂದ್ರೆ 0 volts. High output in the voltage ಎಷ್ಟು ಅಂತ ಚೆಕ್ ಮಾಡಿದ್ರೆ 12 volts. ಆ ನಂಬರ್ ಎಲ್ಲಿದೆ 0 volts 12 volts 4th ಪಿನ್ 7th ಪಿನ್ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ವಿ. ಅದಕ್ಕೆ ಇನ್ನೊಂದು ಹೆಸರೇನು ಮೈನಸ್ ವಿ ಸ್ಯಾಟ್ ಪ್ಲಸ್ ವಿ ಸ್ಯಾಟ್. ವಿಂಡೋ ಕಂಪ್ಯಾರೇಟರ್ ಸೆಟ್ ಮಾಡಕ್ಕೆ ಎಷ್ಟು ಒಪ್ ಆಂಪ್ ಬೇಕು? 2 ಬೇಕು. ಯಾಕೆಂದ್ರೆ ರೇಂಜ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಅದರಲ್ಲಿ ಒಂದು ಇನ್ಪುಟ್ ರೆಫರೆನ್ಸ್ ವೋಲ್ಟೇಜ್ ಕನೆಕ್ಟ್ ಮಾಡಿರ್ತೀವಿ. ಅದು ಎಷ್ಟು ಅಂತ ನಾವೇ ಸೆಟ್ ಮಾಡ್ತೀವಿ. ಒಂದು 5 volts ಒಂದು 2 volts ಅಂತ. ಇನ್ನೊಂದು ಪಿನ್ ಯಾವ್ದಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ? ಇನ್ಪುಟ್ ವೋಲ್ಟೇಜ್ ಆಗಿ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಅದೇ ಒಪ್ ಆಂಪ್ ಅಲ್ಲಿ 8 ಪಿನ್ ಇರ್ತವೆ, ಅದರಲ್ಲಿ 5 ಪಿನ್ ಮಾತ್ರ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಇನ್ 3 ಪಿನ್ ಯೂಸ್ ಮಾಡೋದೇ ಇಲ್ಲ ಯಾವುದೇ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಆಗಲಿ. ಅದರಲ್ಲಿ ಕನೆಕ್ಷನ್ಸ್ ಇಲ್ಲ. ನೋ ಕನೆಕ್ಷನ್ ಅಂತಾನ ಒಂದಿದೆ. ಅದ್ರ ಮೇಲೆ NC ಅಂತ ಇರುತ್ತೆ. ನೀವು ಪಿನ್ ಡಯಾಗ್ರಾಮ್ ಚೆಕ್ ಮಾಡಿದ್ರೆ. Still, if you have any doubts about this experiment, it can be in any language. You can ask Kannada or English. ಕೇಳಿ ಏನಾರ ಡೌಟ್ ಬಂತಾ ಇದ್ರಲ್ಲಿ. ಅಟೆಂಡೆನ್ಸ್ ಕಳ್ಸೋದ್ರಲ್ಲಿ ಬಿಸಿ ಇರಬೇಡ್ರಿ. ಅಟೆಂಡೆನ್ಸ್ ಬಗ್ಗೆ ಬಿಟ್ಟು ಕೇಳ್ರಿ ಇಲ್ಲಿ. ಓಕೆ, ಭಾವನಾ, are you there? Bhavana, are you there? If you don't reply, then I'll mark you as an absent if you don't reply, because you have just sent the attendance and you will sleep, I think. Oh, Bhavana.
Yes, sir.
Okay. Did you understand the experiment? ಅರ್ಥ ಆಯ್ತಾ ಹೇಳಿದ್ದು?
Yes.
ಭಾವನಾ, ಅರ್ಥ ಆಯ್ತಾ? ಬಸವೇಶ್ SP. Basvesh, are you there?
Sorry, sir. My network is not stable.
Okay. ಅರ್ಥ ಆಯ್ತಾ ಹೇಳಿದ್ದು? ಕೇಳಿಸ್ತಾ ಇಲ್ವಾ? Okay. What about this Basvesh? I'll record those names if you don't reply. One is Basvesh. Sri Lakshmi, Iyer Sri Lakshmi, are you there?
Yes, sir. Yes, sir.
ಅರ್ಥ ಆಯ್ತಾ ಹೇಳಿದ್ದು?
Yes, sir. ಅರ್ಥ ಆಯ್ತು.
ಏನಾರ ನೀವು ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡಿದ್ರಾ?
ಯಾವುದು?
ಸಾಫ್ಟ್ವೇರ್ ಸಿಕ್ತಾ?
ಹಾ ಸರ್, ಸಿಕ್ತು.
ಇನ್ಸ್ಟಾಲ್ ಏನಾದ್ರು ಮಾಡಿದ್ರಾ?
ಹಾ ಸರ್.
ಆಮೇಲೆ ಏನಾದ್ರು ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡಿದ್ರಾ?
ಇಲ್ಲ.
ಇದು ವಿಡಿಯೋ ನೋಡ್ಕೊಂಡು ಮಾಡಿ, ಏನಾರ ಪ್ರಾಬ್ಲಮ್ ಆದ್ರೆ ಕೇಳಿ.
ಹಾ ಸರ್ ಸರಿ.
ಇನ್ಸ್ಟಾಲೇಷನ್ ಆದ್ಮೇಲೆ ಜಸ್ಟ್ ಕಾಪಿ ಮಾಡಿದ್ಮೇಲೆ ಜಸ್ಟ್ ನೀವೊಂದು ಇನ್ಸ್ಟಾಲೇಷನ್ ಅದು ಕಳ್ಸಿದ್ದೆ ನೋಡಿ ಗ್ರೂಪ್ ಅಲ್ಲಿ, ಸೆಟಪ್ ಫೈಲ್
ಹಾ
ಕ್ಲಿಕ್
ಸರ್.
ಸೆಟಪ್ ಲೈನ್ ಕ್ಲಿಕ್ ಮಾಡಬೇಕು. ಆ ಇನ್ಸ್ಟಾಲೇಷನ್ ನೆಕ್ಸ್ಟ್ ಕೇಳುತ್ತೆ, ಅದು ಯಾವ್ದೋ ಒಂದು ಲೊಕೇಶನ್ ಇನ್ಸ್ಟಾಲ್, ಅಷ್ಟೇ ಮುಗೀತು.
ಓಕೆ ಸರ್, ಮಾಡ್ತೀನಿ.
ನೀವು 3 ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಸುಲಭ ಇದೆ. ಮತ್ತೆ ಇಲ್ಲಿ ಬರೀ ರಿಫ್ರೆಶ್ಮೆಂಟ್, ಇಲ್ಲಿ ಬಂದಾಗ ಹಾರ್ಡ್ವೇರ್ ಮಾಡೋದೇ ಇರುತ್ತೆ. ಕಾಲೇಜಿಗೆ ಬಂದಾದ್ಮೇಲೆ ನೀವು ಸಾಫ್ಟ್ವೇರ್ ಮಾಡೋಕ್ ಮತ್ತೆ ಟೈಮ್ ಸಿಗಲ್ಲ, ಹಾರ್ಡ್ವೇರ್ ಮಾಡೋದೇ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಹಂಗಾಗಿ ಸಾಫ್ಟ್ವೇರ್ ಮಾಡೋದನ್ನೆಲ್ಲ ಮನೆಯಲ್ಲೇ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿರಿ. ಏನಾದ್ರು ಡೌಟ್ ಇದ್ರೆ ಕೇಳಿ.
ಓಕೆ ಸರ್.
ಮನೋಜ್.
ಎಸ್ ಸರ್.
ಹಾ ಮನೋಜ್, ಅರ್ಥ ಆಯ್ತಾ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್?
ಹಾ ಸರ್.
ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡಿದ್ರಾ, ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿದ್ರಾ ಸಾಫ್ಟ್ವೇರ್?
ಸರ್ ಇಲ್ಲ, ಮಾಡ್ತಾ ಇದ್ದೆ ಅದೇ.
ಮಾಡ್ತಾ ಇದ್ರಾ?
ಹಾ ಎಸ್ ಸರ್.
ಡೌನ್ಲೋಡ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀರಾ ವಾಟ್ಸಪ್ ಇಂದ?
ಹಾ ಆಗಿದೆ ಸರ್, ಡೌನ್ಲೋಡ್ ಆಗಿದೆ.
ಇನ್ಸ್ಟಾಲೇಷನ್?
ಹಾ ಆಗಿದೆ ಸರ್.
ಯಾವ್ದಾರ ಒಂದು ಹಾರ್ಡ್ವೇರ್ ಕಾಂಪೊನೆಂಟ್ ಡ್ರ್ಯಾಗ್ ಅಂಡ್ ಡ್ರಾಪ್ ಮಾಡಿದ್ರ?
ಸರ್ ಅದೇ ಆ ದಿನ ಮಾಡ್ತಿರ್ಬೇಕಾದ್ರೆ ಸ್ವಲ್ಪ ಲ್ಯಾಪ್ಟಾಪ್ ಅಲ್ಲಿ ಮಾಡ್ತಾ ಇದ್ದೆ.
ಮಾಡಿದಿರಾ ಅಂತ ಔಟ್ಪುಟ್ ಇನ್ನೂ ನೋಡಿಲ್ಲ?
ಇಲ್ಲ ಸರ್, ಔಟ್ಪುಟ್ ನೋಡಿದ್ದೆ.
ನೋಡಿ, ಜಸ್ಟ್ ಆ ಸೇಮ್ ಸ್ಟೆಪ್ಸ್ಗಳು ಫಾಲೋ ಮಾಡ್ತಾ ಹೋಗಿ. ಔಟ್ಪುಟ್ ಬರುತ್ತೋ ಇಲ್ಲ ಒಂದ್ ಸ್ವಲ್ಪ ಸಾಫ್ಟ್ವೇರ್ನ ಎಕ್ಸ್ಪ್ಲೋರ್ ಮಾಡಿ. ಡ್ರ್ಯಾಗ್ ಅಂಡ್ ಡ್ರಾಪ್ ಮಾಡೋದು, ಹಿಂಗೆ ಇಟ್ಕೊಂಡು ಹಿಂಗೆ ಕನೆಕ್ಟ್ ಮಾಡೋದು. ಓಕೆ. That is enough for this window comparator. See, another one is there. See this range. What is the application of this window comparator? That is one question. Where exactly we are going to see this window comparator? Can anyone answer for this? Where exactly they are going to use this window comparator? Katyayani, Haridev, Katyayani. ಹಾ, ವಿಂಡೋ ಕಂಪ್ಯಾರಿಟರ್ ಅನ್ನೋದನ್ನ ಎಲ್ಲಿ ಯೂಸ್ ಮಾಡಬಹುದು, ಎಲ್ಲಿ ಅಪ್ಲಿಕೇಶನ್? ಆ ತರ ಒಂದು ಸರ್ಕ್ಯೂಟ್ ಎಲ್ಲಿ ಬೇಕಾಗಬಹುದು? ಯಾರಾದ್ರೂ ರಿಪ್ಲೈ ಮಾಡ್ತೀರಾ? ಈ ತರ ರೇಂಜ್ ಅಲ್ಲಿ ಇದ್ರೆ ಒಂದು ಔಟ್ಪುಟ್, ರೇಂಜ್ ಇಂದ ಹೊರಗಡೆ ಇದ್ರೆ ಒಂದು ಔಟ್ಪುಟ್ ಬರಬೇಕು. ಆ ತರ ಸಿಸ್ಟಮ್ಗಳಲ್ಲಿ ಎಲ್ಲಿ ಬೇಕಾಗತ್ತೆ? ಕ್ಯಾನ್ ಎನಿವನ್ ಟ್ರೈ? ಆನ್ಸರ್ ಎಕ್ಸಾಕ್ಟ್ ಇರ್ಬೇಕು ಅಂತ ಏನಿಲ್ಲ, ಟ್ರೈ ಮಾಡಿ. ಸಾತ್ವಿಕ್ ಟ್ರೈ. ಸಾತ್ವಿಕ್.
ಸರ್.
ಈ ತರ ಅರ್ಥ ಆಯ್ತಾ ಕ್ವಶನ್?
ಹಾ ಸರ್, ಗೊತ್ತಾಯ್ತು. ವಿಂಡೋಸ್ ಕಂಪ್ಯಾರಿಟರ್.
ವಿಂಡೋ ಕಂಪ್ಯಾರಿಟರ್ ಅಂತ ಯೂಸ್ ಆಗುವಂತ ಸರ್ಕ್ಯೂಟ್ ಎಲ್ಲಿ ಬೇಕಾಗಬಹುದು? ಎಲ್ಲಿ ಬೇಕಾಗಬಹುದು
ಸರ್? ಗೊತ್ತಾಗ್ತಾ ಇಲ್ಲ.
ಅಪೇಕ್ಷೆ ಅವರು ಹೇಳಿದನು. ವಾಟರ್ ಲೆವೆಲ್ ಡಿಟೆಕ್ಷನ್ ಒಂದು ಎಕ್ಸಾಂಪಲ್, ಒಂದು ಲೆವೆಲ್. ಗುಡ್ ಥಿಂಕಿಂಗ್. ಈಗ ಅಬೌವ್ ರೇಂಜ್ ವಾಟರ್ ಟ್ಯಾಂಕರ್ ಇಲ್ಲಿ ನೀವು ಎಕ್ಸಾಕ್ಟ್ಲಿ ಇಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ಬೋದು ಅಂದ್ರೆ ಟೆಂಪರೇಚರ್ ಲೆವೆಲ್ ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ಬೋದು. ವೆನ್ ಇಟ್ ಈಸ್ ಮೋರ್ ದೆನ್ 100, ಯು ವಾಂಟ್ ಟು ಶೋ ದ ಮೆಸೇಜ್ ದಟ್ he has some fever. If the body temperature is more than 100, you can throw the message as fever. For that you can use In the same way, if it is below some number, the body is too cold, some other message. In that case, you can use this window comparator. ಸರ್ಕ್ಯೂಟ್ಸ್ಗಳು ಈ ತರ ಸರ್ಕ್ಯೂಟ್ಗಳು ಇನ್ಬಿಲ್ಟ್ ಒಳಗಿರುತ್ತೆ. ನಿಮಗೆ ಡೈರೆಕ್ಟ್ ಸಿಸ್ಟಮ್ ಹೊರಗಡೆಯಿಂದ ನೋಡ್ತೀರಾ, ಒಳಗಡೆ ಯಾವ ಸರ್ಕ್ಯೂಟ್ ಇರುತ್ತೆ ಅಂದ್ರೆ ಈ ತರ ಸರ್ಕ್ಯೂಟ್ಗಳು ಇರುತ್ತೆ. ಯಾವುದೋ ಒಂದು ರೇಂಜ್ ಅಲ್ಲಿ ಇರೋ ತನಕ ಒಂದು ಮೆಸೇಜ್ ಇರುತ್ತೆ. ಓಕೆ, ದಿಸ್ ಇಸ್ ನಾರ್ಮಲ್ ಕೇಸ್. It will show the message that everything, the temperature is normal. When it is outside the range, the body temperature is too high, you have to contact, or you have to take the medicine. If the body temperature is too less, then compared to the normal, take proper medicine or consult a doctor. These messages you can throw by getting the high output and low output. You can program this. Programmatically ಮಾಡಬಹುದು. ಹಾರ್ಡ್ವೇರ್ ಇಂದ ಇನ್ಫಾರ್ಮೇಶನ್ ತಗೊಂಡು ಪ್ರೋಗ್ರಾಮ್ ಮಾಡಬಹುದು. ನೆಕ್ಸ್ಟ್ ಯೂಸರಿಗೆ ಮೆಸೇಜ್ ಥ್ರೋ ಮಾಡಕ್ಕೆ. What you are designing here, it is a circuit. From the circuit, you will get the message. Based on that, you can design the applications. I think you have got the idea about this window comparator. The next question is design the 1 kilohertz relaxation oscillator with 50% duty cycle. 1 kilohertz relaxation oscillator. Relaxation oscillator is the thing, but oscillator means which oscillates. Relaxation oscillator means which oscillates between low and high. That is the meaning of that relaxation oscillator. See, relaxation oscillator are non-sinusoidal oscillators. Non-sinusoidal means there is no sine wave. What it can generate? It can generate that circuit, the relaxation oscillator circuit. It can generate triangular waveform, it can generate square waveform, or it can generate pulse waveform. Using the circuit building blocks called multivibrator. What they are saying is, ಈ ಸರ್ಕ್ಯೂಟ್ ರಿಲ್ಯಾಕ್ಸೇಷನ್ ಆಸಿಲೇಟರ್ ಸರ್ಕ್ಯೂಟ್ ಅನ್ನೋದು, ಆ ಸರ್ಕ್ಯೂಟ್ ನೀವೆಲ್ಲರ ಡಿಸೈನ್ ಮಾಡಿದ್ರೆ ಒಪ್ಯಾಂಪ್ ಯೂಸ್ ಮಾಡ್ಕೊಂಡು, ಅವ್ರು ಹೇಳಿದ್ರೆ ಆಪರೇಷನಲ್ ಆಂಪ್ಲಿಫೈಯರ್ ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ರಿಲ್ಯಾಕ್ಸೇಷನ್ ಆಸಿಲೇಟರ್ ನೀವು ಡಿಸೈನ್ ಮಾಡಿದ್ರೆ ಅವು ಏನ್ ಜನರೇಟ್ ಮಾಡುತ್ತೆ ಅಂದ್ರೆ ಟ್ರಯಾಂಗುಲರ್ ವೇವ್ ಫಾರ್ಮ್ ಜನರೇಟ್ ಮಾಡಬಹುದು, ಅಥವಾ ಸ್ಕ್ವೇರ್ ವೇವ್ ಜನರೇಟ್ ಮಾಡಬಹುದು, ಅಥವಾ ಪಲ್ಸ್ ವೇವ್ ಜನರೇಟ್ ಮಾಡಬಹುದು. ಶೇಪ್ ಗೊತ್ತಲ್ಲ, ಟ್ರಯಾಂಗುಲರ್ ಅಂದ್ರೆ ಟ್ರಯಾಂಗಲ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಇರುತ್ತೆ, ಸ್ಕ್ವೇರ್ ಅಂದ್ರೆ ಸ್ಕ್ವೇರ್ ಶೇಪ್ ಅಲ್ಲಿ ಇರುತ್ತೆ. ಟ್ರಯಾಂಗುಲರ್ ಅಂದ್ರೆ ಇನ್ಕ್ರಿಮೆಂಟ್ ಆಗಿರುತ್ತೆ, ಸ್ಕ್ವೇರ್ ಅಂದ್ರೆ ಎರಡೇ, ಒಂದು ಲೋ ಇರುತ್ತೆ ಒಂದು ಹೈ ಇರುತ್ತೆ. ಆ ತರ ಈ ತರ ರಿಲ್ಯಾಕ್ಸೇಷನ್ ಆಸಿಲೇಟರ್ ಸರ್ಕ್ಯೂಟ್ ನ ಈಗ ಡಿಸೈನ್ ಮಾಡಬೇಕು. ಆ ಡಿಸೈನ್ ಮಾಡಕ್ಕೆ ಅವರೇ ಫ್ರೀಕ್ವೆನ್ಸಿನ ಮುಂಚೆ ಹಳೆ ಸಿಲೆಬಸ್ ಅಲ್ಲಿ, ಇದು ಲಾಸ್ಟ್ ಸಿಲೆಬಸ್, ದೇ ಯೂಸ್ ಟು ಗಿವ್ ಫಾರ್ ಎ ಗಿವನ್ ಫ್ರೀಕ್ವೆನ್ಸಿ. ಮೀನ್ಸ್ ಇನ್ ದ ರನ್ ಟೈಮ್ ವಿ ಯೂಸ್ ಟು ಗಿವ್ ಸಮ್ ಸರ್ಟೈನ್ ಫ್ರೀಕ್ವೆನ್ಸಿ. ರನ್ ಟೈಮ್ ಅಲ್ಲಿ ನಾವು ಲ್ಯಾಬ್ ಅಲ್ಲಿ ಒಂದು ಫ್ರೀಕ್ವೆನ್ಸಿ ಬರೀತಿದ್ವಿ, ಅದಕ್ಕೆ ನೀವು ಡಿಸೈನ್ ಮಾಡ್ಬೇಕಿತ್ತು ಸರ್ಕ್ಯೂಟ್. But now what they have did in the syllabus copy, 1 kilohertz fix ಮಾಡ್ಬಿಟ್ಟು 1000 hertz 1000 hertz ಗೆ ಡಿಸೈನ್ ಮಾಡಿದ್ರೆ ಸಾಕು. They have reduced your work. What type of output you are going to show? Square waveform. ಇಲ್ಲೇನಿಲ್ಲ, ಸ್ಕ್ವೇರ್ ವೇವ್ ಫಾರ್ಮ್. ರಿಲ್ಯಾಕ್ಸೇಷನ್ ಆಸಿಲೇಟರ್ ಇಂದ ಸ್ಕ್ವೇರ್ ವೇವ್ ಫಾರ್ಮ್ ಜನರೇಟ್ ಮಾಡೋದು. ಒಂದು ಹೈ ಔಟ್ಪುಟ್, ಒಂದು ಲೋ ಔಟ್ಪುಟ್. High output, low output. These kind of output where you are going to see. Think about this. First we will see this circuit. See, once again operational amplifier. We are going to use once again the operational amplifier. Same pins, 4, 7, 6, 2, 3, 5 pins. 5 pin use ಮಾಡಲ್ಲ, ಇನ್ನು 3 pin use ಮಾಡಲ್ಲ. 4 and 7th pin are always minus Vsat plus Vsat. Sorry, saturation voltages. Remember, saturation voltages. 6th pin output. 2 and 3rd pin inputs. ಅದಕ್ಕೂ ಇನ್ಪುಟ್ಸ್ ಗೆ ಬೇರೆ ಬೇರೆ ಹೆಸರು. ಒಂದು ಇನ್ವರ್ಟಿಂಗ್ ಇನ್ಪುಟ್ ಅಂತ, ಇನ್ನೊಂದಕ್ಕೆ ನಾನ್ ಇನ್ವರ್ಟಿಂಗ್ ಇನ್ಪುಟ್. ಪ್ಲಸ್ ಇದ್ರೆ ನಾನ್ ಇನ್ವರ್ಟಿಂಗ್, ಮೈನಸ್ ಇದ್ರೆ ಇನ್ವರ್ಟಿಂಗ್ ಇನ್ಪುಟ್ ಅಂತ. This is how the connection. The output here is square waveform. Relaxation oscillator which generates the square waveform The input frequency what we have to give is 1 kilohertz. Then how we are going to design is the question. ಇಲ್ಲಿ ಏನು ಹೇಳ್ತಾರೆ ಕ್ವಶನ್ ಡಿಸೈನ್ ಅಂತ